Hello everyone, welcome to today's interview. I'm Jensen and this is Ali. Today, we are diving into the fascinating world of material science to explore an important concept, polymers. Ali, can you explain what polymers are and in simple terms?
Sure. Polymers are like super long chains made up of small repeating units, similar to a necklace made of beads. And also, these chains can be natural, like cellulose found in plants, or man-made, like the plastic in a water bottle or the nylon in clothes.
That sounds interesting. In fact, polymers are everywhere in our daily lives. For example, car tires provide durabilities and flexibilities, and glue helps us stick something together. The amazing thing is that scientists can adjust the structure of polymers chains to make materials softer, harder, or more heat resistant, depending on the needs.
Exactly, scientists can even use polymers to create tiny particles that are called nanoparticles. These are so tiny and small that they can enter human cells and be used to deliver medicine or important materials to change how cells behave. Polymer allow these nanoparticles to have precise properties and to make them extremely important in the medicine and also research.
Speaking of which, today we are honored to have Maria, a PhD student from University of Manchester, with us. She specializes in these fields. Let's dive into her research.
Thank you so much, Maria, for receiving our interview. Could you please briefly introduce your research to us?
Yes, of course. And first of all, thank you for having me. My research focuses on how we can use polymers for assembling nanoparticles and understanding which polymers can be used for this and what kind of cargoes we can deliver into cells.
That's incredible. I think your research has both significant value in medicine and also academics. Could you please explain it more to us?
Yes. So both in medicine and industry, they're very useful techniques to use because we can introduce different type of instructions into the cell so they can synthesize different proteins or drugs that we can use. In an academy or research, it's very useful to understand how the cells are expressing the genes that we are genetically modifying. So yes, it's a big advancement in research.
Oh, it's inspiring. And do you have any hopes and plans for the future of your research?
Yes, so for like the aims or the goals of my research will be generally to reduce the time that it takes to synthesize these polymers. So by doing like different type of screenings, we can reduce all the time. And in general, like personally, I would like to start getting into the industry, maybe developing a career and making like new type of reagents using these polymers for both gene delivery and drug delivery.
Great. Thank you for sharing. We wish you great success with your research.
Thank you very much.
You're welcome. As Maria mentioned, her research focuses on developing efficient ways to identify the best polymers for making nanoparticles. These nanoparticles can deliver drug or DNA directly to target cells, improving the accuracy and effectiveness of treatments.
Exactly. You could think of her research as designing a precision delivery tool for medicine. For example, delivering drugs specifically to cancer cells without affecting healthy ones. This approach not only makes treatments more effective, but also significantly reduce unwanted side effects.
Beyond medical treatments, these technologies are also important for scientific research. For example, scientists can use nanoparticles to label cells and make them easier to observe and track. This also helps in studying how cells behave and understanding disease more deeply.
Oh, that's really meaningful. It's like giving scientists a better magnified glass to see biological process clearly. This can accelerate the development of new medicines and improve disease diagnosis.
What's even more exciting is how this research contributes to personalized medicine. In the future, doctors might use nanoparticles to create treatments tailored to each individual's unique biology and make healthcare more precise and effective.
Yes, especially for complex disease, this technology could move us away from one-size-fits-all treatments and towards solutions designed for each patient's specific needs.
In summary, Maria's research not only improves polymer science but also the groundwork for using nanotechnology in biomedicines. It has the potential to revolutionize how we treat disease and conduct research.
We hope today's interviews has given you a clear understanding of innovative technologies and its potential to improve our lives. We're so excited to see these breakthroughs come to life in the future. Thank you.
Thank you.